Hello, this is a overhanging beam. It's an overhanging beam that we need to calculate and draw the shear force diagram and the beam diagram, the bending moment. So we had already tackled everything. This is the UDL point loads. Now we want to find the reaction at A. The anti-clockwise moment along this equals to the clockwise moments. So wait, find the clockwise moments about A. So we start with A with 5 newtons, 5 kilonewtons. About A is 5 times 2 because it's the force. 5 kilonewtons times distance give us moment plus the UDL that we will multiply these two times the distance 2, then half distance which acting upon to A. This will be this 2 plus 1, we get 3. Then we move on to 3. Here we multiply the force 3 times the distance 4. 3 times 4. Then we move on to 1.5 kilonewtons. It's a UDL, so we multiply 1.5 kilonewtons times the distance 2, then have the distance which is acting upon, so we get 1 plus the whole distance now 2, 4, 6, 7 times 7, and then last but not least, in the clockwise movement we have this 2 plus 2 plus 2 plus 2, which is 8 times the 2 kilonewtons. 2 times 8. Then we move on to the anti-clockwise moment which are causing the anti-clockwise about point action A. So we have B, which is 6 meters away, so the action B times distance of 6 plus the UDL on the other side to produce a hogging moment. So it will be 1.5 times 2 times half the distance taken upon. So in our maths we'll have 6RB plus 3 is equals to 71. Is equals to 71. We take 3 the other side. 6RB is equals to 68. So RB is equals to 11.33 kilonewtons. So what about if you want to find the reaction of, so the reaction B plus reaction A, the sum of the upwards moment and the downward moment will always be equal to 0. So you may equate them to find the reaction at A. So we multiply 1.5 times 2. 1.5 here times the distance which it's acting upon. Then we add 5 kilonewtons, which is a point rod, plus 2 kilonewtons times the distance acting. And then we add the 3 kilonewtons here, which is a point rod. We come again, we add the 1.5 times 2 plus 2. Hence we will have 11.33 kilonewtons plus add A is equals to all this 1.5 times 2 plus 5 plus 2 times 2 plus 3 plus 1.5 times 2 plus 2. So the array, when we take this figure on the other side to subtract, then hence we will find the value 8.67 kilonewtons for A. Kilonewtons equals to reaction A. So our reaction A here, reaction A is equals to 8.67. The reaction B here we have 11.33 kilonewtons. Don't forget that, kilonewtons. Then let's find the shear force tabulation. The shear force at C, I'm sorry I had not dimensioned to indicate where is C. A is C, then we have D on the far end, D, then F, then G. Then we have D, E, then F. So the shear tabulation at C is 2 kilonewtons. As we know that the clockwise moments are positive and the anti-clockwise moments are negative. So in shear force, so the downward point rod will produce a positive. So the shear force at B or before B will be equivalent to 2 kilonewtons plus 1.5 times the 2 times the 2, 1.5 because of UDL multiplied by 2, and then we have to add the other 2, of which both will be positive. Then the SF tabulation at B will be SF tabulation at B will be 2 to make the work easier. We won't repeat the values again. Let's say 5 kilonewton I've got here, plus at B we will subtract the 11.33 because this is the anti-clockwise moment. It's producing a negative, so we find the negative 6.33 kilonewtons. There's F at F the shear force at F is point, or we may take even before, but it's not necessary because there is no load in between. Take before will be the same as negative 6.33 kilonewtons. It won't change, but the shear force at F will be the negative 6.33. You add 3 kilonewtons for the point load, which will give you a negative 3.33 kilonewton. Then the shear force at before point E before will be negative 3.33 kilonewtons. 3.33 kilonewtons you add the 2 times the distance, and you add 2 kilonewtons, you multiply by 2 because it is 2 kilonewton per meter. Now we want to find out, we are multiplying to find out the other meter it is acting upon. 2 times 2, so our answer will be 0.67 kilonewtons. or before. Then SF E, at E we take the 0.67, we add yet again the 5 kilonewtons, give us 5.7 kilonewtons. Then the SF before A before give us is actually this value. It will remain the same, to be 5 kilonewtons. Then the SF at A will be 5.67. You subtract this value here, 8.67. Then we have a negative 3 kilonewtons. Then the shuffles at D. We all know the answer. At C will be equal to 0, but we may calculate to be negative 3. We add 1.5 times 2. 1.5 times 2 give us 0. So let's plot. To plot the SF diagram, we have A, we have E, we have F, B, C. From our calculation, the SF tabulation of 2 of C is 2. So we are at a point here 2 kilonewton. Because of the then before B we have 5 kilonewtons, so let's come here to 5 kilonewtons. Because of the UDL, this is slanting line. We have that slanting in line, then 5 kilonewtons, that is before. Then B after is negative 6.33. we go up to the negative 6.33. no need to write the negative because if you go on the other side of the Cartesian plane is negative, so we indicate here this is positive, negative B. Then SF before F, it's negative, no load acting, so we we move straight. Then SF. SF at F is negative 33, somewhere here. This is negative 6.33. Now this is negative 3.33 kilonewtons. Then the shear force at before E. Before E it's 0.6, a point here 0.67. Because of the UDL here, it's another slanting line. Got another slanting line there. Now you are before, then at E it's 5, actually 5 kilonewtons. 5.67 is slightly above there. And because of no load here, the middle, you have a straight line like that, and then from the straight line you can get the other point that was before A. Point before A, 5.67. Then at A it's negative 3, all the way down here, somewhere here. So we go down to business, negative 3. We lied only 3. Then our point D, SF, I'm sorry for misleading you here, it was point D. D for distinction. We go back to point 0 because of the UDL. This is the straight line, so it's not a parabola. So we shade to show that it's negative, positive, negative. That's the SF diagram. So if need be, you may find the maximum BM, it will occur with the diagram. The maximum BM, and it will occur where the SF changes sign from negative to positive. So using similar triangles, it's easier to find the distance here where the sign is changing this point. So we just equate, we say let this point be x, and automatically the other point will be 2 minus x. Okay, let's use the similar triangles to find it. So we take the 0.67 is equals to x here. 0.67 is equals to x over, then we divide it by 3.33. 3.33 is equals to 2 minus x. Then we cross multiply. Hence we will have an equation that says 1.34 is equals to 4.0x. So our x is equals to 4.0. So the equation will be equals to excuse me, it's equals to 0.335 meters. Equals to 0.335 meters. meters. So let's find the maximum, where the maximum BM will occur. So we have the meters, we have this point, let's extend it up to the top. At least we know x now is equivalent to 0.335 meters. That is the point x from here to here, 0.335 meters. So we just take the 8.67 kilonewtons from point A, from the direction A, all the way to here. So we add the force times the distance. The distance will be 2, add 0.33 meters we've gotten. So our reaction here will be actually 8.67 kilonewtons times 2.335. You subtract the other forces, 5 kilonewtons. You subtract the UDL here, 1.5 times 2. then times the distance it is acting upon. So it is acting at half here, so it will be 1 plus 2 3 3 plus 0.335 get times 3.335. Then we subtract another force, 5 kilonewtons, to be actually 5 kilonewtons times 5 times 0.335 is actually the force times the distance x. Then we subtract 2, subtract this one, 2 kilonewtons times 2, the distance, this distance, 2 times the distance of action, which will be 0. It will be actually 2 kilonewtons, 2 times the distance 2. The distance not true, it is 0.335 times 0.335 times half the distance of action, it will be also 3.335. you divide by 2. If you key in the calculator, your answer will be 8.452 kilonewtons per meter. That's the maximum BM. Now it's time to find the BM, tabulation, bending moment tabulation. At point C, the BM at C is equals to 0 because the moment at 0, the distance is 0, so we can find them. Then the BM at B is equals to 2 times 2 kilonewtons times the distance 2. Then because we're moving downwards, it's causing a hogging. It's negative. It's negative 2 times 2. You add then the BM at B, also don't add here, we subtract because it's also producing a hogging moment. We'll subtract 1.5 times the 2 times the distance of action, which is half these two, 1. So the answer will be negative 7 kilonewtons. So the BM tabulation at F will be equals to negative 2 times distance of 4. 2 times the distance 4. You subtract 1.5 times 2 times the distance of action, which is 2, plus half the distance of 2, which is 3. Plus 11.33 because it is producing a hogging moment. So times 2. Times 2 and hence the answer will be 5.66 kilonewtons. Then we go the BM at E, point E. I think at point E it is easier to get the BM from the other side, so it will be 1.5 times 2 times the distance of action, which would be 3, and it's actually negative because of the hogging moment. So 1.5 times 2 times 3, then there is also the subtraction of 8.8 8.67 you add times 2. The BM at E will be 8.34. Note there will be a difference in the answer because of the rounding off. If we calculated from C, we would get 8.32, but because of using the other side and because of this rounding off of this direction A and B, we get 8.34. So I would advise you to use only one decimal place because to give you 8.32 whatever way you use. So BM at A is equals to negative 1.5 times 2 times 1, which is equals to negative 3 kilonewtons. And then the BM at D equals to 0. So let's draw the shear force, no, the bending moment diagram.